my screen. Hey, throw your name on here. As a general rule, I think most notes in Unit 2 have a front and back because the graphs and the tables take up so much space that I'm not able to put enough examples on just a front. So, Mrs. Ho, this is second hour. Okay, so today we are finding slope from a table, and we are also looking to see whether the relationships that we are given in our tables are linear or non-linear. Linear means that a relationship is a line. So the word line is right in that. Don't pronounce it line R, though, but that has the same root meaning. Okay, linear means you have a consistent rate of change or a consistent slope. Those mean the same thing. So rate of change is another word for slope. If you still have a Chromebook out, put it away. I've already asked. You weren't here, but I've already asked. Okay, consistent rate of change or a consistent slope. So what that means is as we are climbing a mountain, we're going at a consistent rate. We're not going way faster and then way slower and then way faster and then stopping and then going fast. So we are looking for something that has a consistent rate of change. Making a straight line, therefore it would be linear. Okay, we learned yesterday that slope was our rise over run. Today we are adding in that slope can also be defined as the change in our y values. So change in y over the change in our x values. That is the same thing. So change in y values over change in x values. Your y values are on your y-axis, they're going up and down, so that's the same thing as your rise. How much you're changing up or down is your rise, how much you're changing side to side is your run. So it's just a different way to say the same thing. The universal symbol for change is a triangle. It's like a Greek letter thing. So if you want to abbreviate this, you can abbreviate it to change in y over change in x. Okay. So our plan is we're going to start by finding the change in our y values and the change in our x values. After we find that, we then have to ensure that that change is consistent for every single different level of our table. So your tables today have 4 values on them. I think the ones on the assignments do too. Yeah. We could make the table smaller or bigger. We just 4 seemed like a good amount. You have to ensure that that rate of change is consistent the entire time. Once you do that, you are going to circle whether it is linear or non-linear. If it's consistent, you're going to say it's linear. If it's not consistent, you're going to say it's non-linear. And then you are going to find a slope if it is linear. If it is not linear, it doesn't have a slope because it's not a straight line. So you don't do that part if it's not a line. Okay? So, coming down to our table, the first thing that we need to notice, just like ordered pairs go x and then y, our table, this is a list of x values, this is a list of y values. So this would be like saying I have an ordered pair at -1, 5, at 0, 3, at 1, 1, and at 2, -1. That's just 4 ordered pairs. It's just written in a table instead of being written in a list. Once you have those, you are going to look at the change that happens in your y values at each row of the table. So right here, to get from 5 to 3, what do we do? What's the difference between 5 and 3?
-2.
Well, you're going down to -2. So I'm going to put a little arrow here and write -2. They can wait, or they can send me a message. From 3 to 1, how much am I going down? 2. I'm going down to there as well. And then from 1 to negative 1. How do I get from 1 to negative 1? Minus 2 again. So my change on my y values is all consistent. Who's calling me? The fact that they're calling me on this phone. Hello. Yes. Yeah. Okay. Back to my video. Okay, so on our y values, we're going down 2 every time. On our x values, our change in our x values from negative 1 to 0, what do we do? We're going up 1. Okay? From 0 to 1, what do we do? What? How do we get from 0 to 1? Up 1. Okay? And from 1 to 2, what do we do? Up 1 as well. So, this one, that rate of change is completely consistent. Every single row of my table, my y's go down by 2, my x's go up by 1. So if that's consistent all the way on both sides, I know this is linear, so I can circle linear. And then my slope is the change in my y values over the change in my x values. So it's negative 2 over 1. Okay, any questions about that first one? Hey, let's go look at the next one then, right next to it. So, I always start with my y's because otherwise I forget they go on top. So, from 2 to 3, I'm going up 1. From 3 to 5, what am I doing? I'm going up 2. And from 5 to 9, what am I doing? Up 4. Okay, so at this point you might be tempted to say this is not linear. You need to check both your x values and your y values to see if the ratios are still linear though. So right now, I'm not going up a consistent amount each step. I need to go check my x's. So negative 1 to 0, 0 to 1, 1 to 2, it's the exact same x's over here. I'm going up 1 each time here. So this one is not consistent because I'm going up 1 when I take 1 step, up 2 when I take 1 step, and up 4 when I take 1 step. So it is not consistent. It is not a straight line. So you circle nonlinear. Mark off that box. Yes. What do you mean, x is 0? Yeah, so it could be just a completely horizontal line. So this first one, if I were to graph this, let me zoom out and get my little dry erase board graph that I just had. So this first one, if I were to graph it, I would graph negative 1, 5, 0, 3, 1, 1, and 2, negative 1. See how that's a straight line? Okay. I don't know why this is so difficult to erase. See more friction. Hey, this next one, if I were to graph negative 1, 2, negative 1, 2, 0, 3, 1, 5, 2, 9, that's not a straight line. That will go whoop, okay? So what we're looking for is, does it make a straight line? Hey, back to our examples. We've got 2 more. This next one I need you to pay super close attention to the details of. Because this is where things get a little tricky and you got to turn your brain on. And it's not just super straightforward. Change in my y values. From 1 to 3, how much do I go up? 2. From 3 to 5, how much do I go up? 2. And from 5 to 9, how much do I go up? 4. Okay. So you might be tempted to say right now, this is not linear. But wait. From negative 5 to 0, how much do I go up? 5. From 0 to 5, how much do I go up? 5. From 5 to 15, how much do I go up? 10. Okay, so now what we need to look at, my slope, oh God, people keep sending me like urgent messages. My slope here is 2/5. My slope here is 2/5. My slope here is 4/10. Are 2/5 and 4/10 the same thing? Yeah. 4/10 would reduce to 2/5. So essentially what this is if I just like skipped a stair here, that's why it takes me further. So this one is linear because the ratio is consistent. Eric, take the phone out. All right. Last one here. We've got 7, 6, 5, 3. So 7, 6, 5, I know is going down 1. And then 5 to 3 is going down 2. Right here, I've got 1, 2, 3, 4. So those are all going up 1. Up 1, up 1, up 1. On this one, -1 over 1 is not the same thing as -2 over 1. So this one is non-linear. But you do need to check to see if there's a chance that those fractions do equal each other. All right, any questions right now? Hey, flip this over then. We've got 2 more on the back. The 2 on the back have graphs. And so instead of using the table and finding the rate of change on the table, we want you to practice putting these tables onto a graph. And it's going to be more practice of graphing those ordered pairs. So what we've got to remember is that these are ordered pairs x comma y. We're just going to go put those all on the graph. So -3, 1 means I go left 3, up 1. 0, 3 means I go over 0, up 3. Two, 6 means I go over 2, up 6. Right 2, up 6. And then 5, 7 means I go right 5, up 7. Is that a straight line? No, it almost is, but that one is off, okay? So you got to be super precise when you're graphing, and then you can't just assume, you got to actually check. So that one's non-linear, and we are not going to find a slope because it's not a line, so we can't find a slope. Hey, last one we've got, another one we're going to graph. What do you notice about this one? The x's are all the same. Yes. So we're still going to graph it. We've got 1, -2. So we go right 1, down 2. 1, 0. So over 1, up 0. 1, 2 would be right 1, up 2. And 1, 4 would be right 1, up 4. Okay, is that a line? Yeah, those are perfectly in a straight line. That one is linear. What is the slope of this line? Undefined. Okay, I want to show you guys, if you were to get one that looks like this on a table without a graph, you would go and you would say, okay, well, my change in my y values is always up 2. Going up 2 every time. My change in my x values, how much is my x value changing here? 0. So up 0, up 0, up 0. Then I would go to try to make that a fraction. I would do change in y over change in x. What is 2 over 0? Undefined. So when we see that 0 on the bottom of the fraction, that's how we would know it was undefined, even if we didn't have a graph. All right, glue these puppies into your notebook, please. And